Rehearsal for the musical Beauty and the Beast begins tomorrow. February 18th.
I want you to have every minute possible for your quiz. Get going.
All students are invited to draw a mascot, draw a sign, 4 p.m. Tuesday morning. Mr. Whiteberg is going to collect art supplies and music provided. Mr. Nail in the meeting for all those who signed up for the French trip. That meeting will be in her room Tuesday, tomorrow, February 8th, 5 o'clock. Anyone unable to attend needs to see Miss Character, Miss Deviation process. If more interested in playing tennis this spring, stop in that King's office, sign up. First practice is March 14. This week's Spartan lifters of the week, Sophie Guttmiller and Parker Reedy. Great work. Both of you enjoy your parking spots outside the remainder of the week. Also, if you signed up for the Learning How to Cope with Everyday Stress in a Therapeutic setting, that starts tomorrow during the start time. See any of the counselors for more information. Flyers are hanging around. You still can sign up. Oh, please stay. To the flag.
Give you 2 minutes to finish this up. Okay, we shouldn't need 10 minutes for this. If you know your function rules and the behavior of the functions, it takes about 30 seconds. Okay, if we're a little rusty on our function rules and types, Calculator Mojo gets you there in about a minute. Who's still rolling? Hopefully putting up with the video wasn't too bad. No flashbacks of 2 years ago. Just a recorded class, so. I had a couple ask, I don't remember if I sent it out to the whole group. The end behavior and extrema stuff won't be on the quiz. I printed out the quiz and it was ready for Friday. I just wasn't able to be here. So your quiz goes through continuity test. So it's like combinatorics, prob stats, analysis of graphs, that kind of stuff. Okay. All right. If your kung fu is strong, you remember how rational functions work. Degree is the same numerator and denominator. I'm going to have a horizontal asymptote at A over B. So if I have a horizontal asymptote there, that means that's my end behavior. Done. Okay. If we remembered that. If we don't remember that, then we'll just jam it into the calculator and spam 9s on either end. See what the calculator tells me. Okay. This one, it's going to have it's not a vertex, it's like an origination point at, if you remember your transformations, horizontal translation, right 3, up 1. And it goes off into the wild blue yonder. Which means the limit as I approach infinity, oh, that's g of x. Limit as we approach g of x, or limit of g of x as x approaches, there we go. Infinity is infinity. And we specifically talked about as x approaches 3 from the right, y goes to 1. Because remember, I can't actually approach negative infinity because the graph doesn't exist back there. We had said the way that this book does it, the way that both Mr. Spear and I do it for PreCalc and Calc, is we say as I approach 3 from the right. Now, if you know the functions, cool, that's it. 30 seconds, it does this, those are my limits, I'm done. If not, I go and dump things in here, and if I want to know their end behaviors, I will switch my table over to ask, and I'll say as I go all the way to infinity. The first one, limit was 4 as I went to infinity. Second one, it was getting closer and closer to infinity. If I go to, oh, I had a point in there, didn't I? Oh no, that's scientific. Okay, negative. You know what, just for grins. Five. I don't recommend those, they hurt. Again, I get 4. And, well, it doesn't exist as I go to negative infinity. That means the function doesn't exist back there. So that's where you would have to go back to your graph and say, well, why does it say error? Yeah, that's the first one. There we go. There's blue. Okay, the second one, it didn't even start until 3. So maybe I trace my blue one to like 3.00001 and say it's getting really, really close to 1. So if you separated this into positive infinity, negative infinity, cool. I think I say every semester that if it's the same for both, you can just put plus or minus. Oh, here we go. Do we have limit notation for all 3? Did we have the correct limit for this guy? Correct limit that guy? Correct limit that guy? Did we remember our notation that we can say 3 from the right? Or if you even said like 3 and then parentheses, right. Okay, good enough. Something to denote that we can only approach it from that side because that's where the domain starts. Okay. So there's our end behavior stuff. Nothing about extrema yet. Anything from 1-3, 1-4? Because was the homework a little bit of both, or was it just 1-3? I can't remember. Little bit of both. Okay. So back half of 1-3. There was a couple who came in to ask this morning. There's one who asked this weekend. Like, just quick review before we hop in. What are the 3 types of discontinuity? Jump, removable, and infinite, and they occur at specific spots. Jump happens when? Piecewise function. Now, just because it's piecewise doesn't mean it has to have jump discontinuity there, because one might end where the other begins. But that's the only time it can happen. Removable. Whenever I have a rational function, factor, because you might be able to cancel something out, and if I remove a factor, I have removable discontinuity. And infinite is whenever I have that vertical asymptote. Again, x on a denominator, vertical asymptote, it infinitely, whether they're going to the same place or different places, it's going to infinity, so infinite discontinuity. Okay? It's those 3 things. You're just looking for those 3. And after we do this continuity test stuff, like literally after today's quiz, I don't know if you're ever going to have to do the continuity test again, but you will have to know how to find the discontinuity. You're just gonna, I'm gonna throw a function at you and say, what's its continuity? And you just gotta know those three things. Okay? What about from 1-4, the beginning of extrema? I would hope the extrema part was actually easier because, I mean, y'all did relative, maximum, minimum kind of stuff in Algebra 2. So, nothing? On 1-4? Okay. Well, come on, you. 32. Poke. Nope. Poke. Oh, there's a whole lot of 32. Poke. Really? Across 2 pages? All right. 2-inch margin on each side, 4-inch margin on top and bottom. Okay. So I got a box. This is 2. This is 2. This is 4. This is 4. Okay. The design, including the margins, should have an area of 392. What overall dimensions will maximize the size of the thing? That's 32 from 1-4. Oh, you had nothing from 1-4. Oh, okay. All right. Roller coasters. Whee! Okay. Speed of roller coaster if it drops from the height is this function. Okay. Now, you start using this notation, kids start freaking out. Remember, this is height at point A, height at point B. The A and the B subscript just denote which one. They don't have mathematical operators. So, g is acceleration due to gravity, the 9.8 meters per second squared. What happens to the function as the h of b decreases to 0? Common sense. H of b is the height at point B. So what happens as this gets closer and closer to 0? Right? Because I'm taking height at point A minus nothing. So it's the entirety of point A, meaning it's the entirety of the speed. I'm not measuring the speed from here to here. I'm measuring the speed from here to there. Isn't it going to be faster at the bottom? You all rode a roller coaster, right? Okay, if I measure your speed about 30 feet past the crest versus your speed at the bottom when all of that momentum makes your butt sink into the seats, right? That's a very different speed. When the height approaches 0 on the back end, that means what's my speed when I get all the way to the bottom? And it's going to approach that, whatever the maximum speed was. Okay, it's kind of like the whole, you've heard of terminal velocity, something being dropped out of an airplane. Like if you got someone who hops out of an airplane and they do the spread eagle thing all the way down, eventually you're going to accelerate, and then just kind of be that speed. It is your terminal velocity where your acceleration will balance out against your wind resistance. That's the fastest you can go. Unless you needle drop. Like, I don't know, if I fell out of a plane without a parachute or nothing, I'd probably just needle drop to make sure I don't want to walk away from this. If I live after this, this is bad. Okay? And other people are going to do the, like, Moana hitting the water. Smack. Right? I could watch that all day. What else? Okay, cool. Mix yourselves up. Don't sit next to someone you normally sit next to. You're about to take a quiz. I want you to scramble up. Yeah, but I'm going to give you the review, and then we're going to do the review so that immediately we can go into the quiz. You're like, no review! No, we're going to do the review. I just want you to mix it up now. Okay, you should not be sitting at the same table with anyone you normally sit with. Move. Move, move, move. So if you got a table full of 4 people, 2 should probably be moving. So you can mix and match.
No, I don't want to surprise you. Or chipper. That's kind of odd.
Womp. 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 3, 4, womp. Go.
Problem 3, that narrow?
Yes. Okay. So we should have scribbled out at the top. It's a review, not a quiz. Oops. Copy paste. Bad stuff. Round 1 is our combinatoric stuff. Remember, there is a formula to it. You want to say, how many category A things am I choosing? How many category B things am I choosing? And you keep doing that for however many categories there are over your total objects and how many will be chosen for your group. Okay, combinatorics takes a permutation or combination, depending on whether order matters, your fundamental counting principle that says category A times category B times category C is your total number of ways possible, and combines it with probability, number of favorable over number of total. So, round 1, 300 squirrels in the park, 35 are sober. Due to fermenting fruit under the trees, that is a real thing. What is the probability that if of 20 squirrels that you capture for observation, 15 are drunk? We lived across the street from the park. A bunch of berries and apples and stuff would fall down on the ground, and we would like set up camp chairs and watch squirrels try to climb up a tree, collect his thoughts, try to get up the tree. It was hilarious. You can spend all day doing that. Or the moose that wanders into the grocery store in Alaska after eating the apples on the ground. They're drunk and looking for munchies. It's great. I have 300 total squirrels. We are capturing 20 of them for observation. Doesn't matter the order that they're captured. No. So it's a combination. Up top, what are the different categories of squirrel we're talking about? Sober ones and drunk ones. So how many sober are there to choose from? How many in this particular specific example will be sober? 5 of them. How many drunk squirrels are there? Oh no. Way more. If 35, that's a lot of drunk squirrels. Okay. And how many of those are we capturing? 15. And I'll jam it in my calculator. As I plug that in my calculator, I can either alpha y equals brings up my fraction menu and just type it like that. Say there's 35. Alpha window brings up my shortcut menus. 8. I'm going to choose 5 of them. Parenthesis, parenthesis. 265. Choose 15 of them. Get back up there. And downstairs 300. And I'm going to choose 20 of them. And turns out the probability is actually decent. These are all going to be very, very small probabilities. Like, I don't think I've ever seen a combinatoric problem go past 20, 30% because you're asking for a very specific outcome. Now, for anyone who's rocking a scientific calculator or an 83, you just have to use a lot of parentheses. That's it. You would need another set of parentheses here divided by a set of parentheses here. Okay. So I'll say about 4.9%, because that's 3 decimal places. Okay, box and whisker plot for a set of data and tell me if it's consistent or inconsistent using the mean and standard deviation. We don't do statistics by hand anymore. We're big kids. Where does it go? How do I plug it in? Stat. Edit. Start typing. 70, 50, 30, 40, 35, 30, 30, 40, 15. Right? 23, 23, 23. Yep. Okay. 2 ways to make your box and whisker plot. Number 1, stat calculate my one variable stats, or however your calculator runs it. Don't worry about your frequency list, just go for it. And the 5-number summary will always be there. If you're going to do a 5-number summary version, don't just generic this and label, because I want a box and whisker plot that is proportional to my data. So if I said this being 15, 30, 35, 45, 70, maximum quartile 3, median quartile 1, and minimum. Okay, so there's way number 1, just make sure that it's proportional. If I saw this, I'd probably dock a point, because I can also find my graph how. Right above y equals says I will plot my statistics. Turn plot 1 on and make sure that it's box and whisker plot. Now, if I hit graph, first of all, it's going to go back to these. Clear, clear. If I hit graph, It's not going to show me too much because none of my data points are in this 10 by 10 zone. I want to zoom to my statistics. You see how that box and whisker plot does not proportionally match up with the generic thing that I drew before. Okay, so if you're going to use the 5-number summary to make the box and whisker plot, then like just make a quick number line. Just sketch out a number line, go by 5s or something, and then fit the data in. Now, if I just sketched this ballpark on my paper, then hit trace, look at all the stuff it gives me. Okay. So if I get my stat plot over to a box and whisker plot and just hit trace, not only do I have the graph in front of me so I can sketch something that's proportional, but I can also trace it and it'll find those 5 special numbers. Okay. So number 2's got a lot going on because it's all basically review of Algebra 1. It's just the last couple of years have been an adventure. Okay. Now it does say, create the box and whisker plot for the data. Okay. So, a little more this way, a lot more that way. When you make your box and whisker plot, make sure that you label that this is minimum, quartile 1, median, quartile 3, maximum. Label what those are. I remember 15, 70, 45, there was a 30 somewhere. Oh, 30 and 35. Okay, so I want it to be somewhat proportional. Describe the data set as consistent or inconsistent using mean and standard deviation. So right now, if I was just looking at my box and whisker plot, do you think this is a consistent or inconsistent data set? Is it nice and compacted together, or is it spread out? Okay, so I know it's inconsistent, but I have to use my mean and standard deviation to get there. Those were also on my 1 variable stats. Okay, my mean, my standard deviation. Do you remember which one we were using? Okay, little sigma x because I have the entire population versus a sample. Now, if they said this data represents several of the, I don't know, the juniors' chemistry tests. Well, I don't have all juniors' chemistry tests, so it would have been a sample. I would use big S. But since this is just a list of numbers, I have to assume that's the entire population, so I'm going to use this. So I plug those in, or I plug my data in, I go to my 1 variable stats, and I say my mean is approximately 3778, and my standard deviation is approximately 14, I can't even write today, 1455, approximately, you just said it. There you go. Now I don't remember what I said when we actually did our 1 variable stats or not, because again, we went through pretty fast. It was stuff that theoretically you should have just done in Algebra 2. For something to be considered normal, a normal distribution, my mean is 15% of my standard deviation. I suppose I can't even see my decimal there. In fact, z-scores, like stuff that's used to measure intelligence, ability, academic capability, reasoning, perception, those are all done on a z-score in which you have a mean of 100 and a standard deviation of 15. So take 1455 divided by 3778. What percent of our mean is the standard deviation? It looks a lot more than 15%. 38%. So my standard deviation is almost double what it should be. Standard deviation is a measure of how spread out things are. This is saying my data is about twice as spread out as normal. So that is very inconsistent. So you have these two, and then you say this is inconsistent. Okay, if I'm looking at this for points, do you have, you know what, not even that. Do you got the right numbers? Did you say inconsistent? Do you have the right numbers? Is it labeled? Is it proportional? Okay, is kind of how I'm looking at it. Just like daily quiz, 5 points each. So life happened hard. I will put your quizzes from last time in, like, right meow while you're doing your test. Y'all, there's a lot of kids who just got dinged on little stuff like tell me in radical form and exponential form, and just didn't do the exponential form at all. Double check the directions, make sure that you did everything, because the quizzes are small, 5 points each question. That also means that just not doing part of a question because you didn't read the instructions might take you from a 100 down to a 90. 3 points. Okay? Read the instructions. State, domain and range in both set builder and interval notation. Domain is my x's. And we're just asking, does it exist? Brrr. I know it's really hard to see. I use the crappy graph on here. The better graph is on the quiz, so you can actually tell what's up. But if there's ever, like, who was it? Finn, I think, just asked, is that an arrow or a dot? That's a question you can ask. It's a question of clarification. Okay, so this is a arrow. This is a arrow. So when does my x's start existing? Arrow, negative infinity. Okay, what about right there at -2? Still exists because I got a closed circle down here. So now I'll follow my parabola. Brrr. Still exists. So what's my domain? All real numbers. Yep. So in interval, negative infinity to infinity. In set builder, all x's such that, well, what's the rule if it's everything? I don't have to put the rule part. I can just say x is an element of the reals. I don't need the rule part if it's the entire real number set. Now, if you wanted to be redundant about it, if you wanted to say negative infinity is less than or equal to x is less than or equal to infinity, suppose I can't say or equal to, right? That's an R. That doesn't even look like an R, but I'm going to say it's an R. If you wrote that, I wouldn't hold it against you. It's overkill. This is Mr. Sirman, but it works. Range. This is a closed circle. When does it start existing? Okay, so we've got -4 until, remember we have to assume that it exists there, otherwise we're just left guessing forever. So I'm going to say until 0 with a bracket. A union, because I need to jump from one set to the other. And then this part doesn't even really matter because this goes forever. So I'll say union 1 to infinity. In set builder, I'm going to need that as a compound inequality. All y's such that -4 is less than or equal to y is less than or equal to 0, or y is greater than or equal to 1. Now that I think about it, that might be the first time that you've ever seen a compound inequality that involves both an and an or statement. Yeah?
Can we exclude the union and interval notation, just have it like the brackets that, and the, like, just a coordinate thing?
Rephrase.
Can we get rid of the U and still have full point? The union sign.
In interval notation?
Yeah.
No, because intervals are sets, and you need the union to combine the sets. Okay? So, kind of a combination of do you know interval and set notation with do you know domain and range. Next up, graph analysis. The approximate numbers of annual visitors to a park, 2000 through 2008, because that's when this book was written. I got a big function where x represents the years since 2000. So I got a graph, I got a function. Find the number of visitors in 2006. I cannot just wing it and say 16.8 thousand. How do I find it for real? Yep, whether you want to go manual on it and just plug 6 in all of those, or probably more helpful, go over here and plug the function in. 0.05 x cubed minus 0.51 x squared plus 1.81 x plus 1335. I didn't? Come on, Frank. Fat finger syndrome ain't supposed to work when you're on a, like, there we go. All right, so I got the function in. If I want this exact graph, remember it tells me my window right here from 0 to looks like 23. Oh, doesn't that kind of jump? Y'all remember the little lightning bolt from back in algebra half? Okay, tells me I get to jump from 0 up. So I'm actually going to start around 15, go to 23, and then 0 to 10. 10? 9. So my window will go from 0 to 9 by 1s, from 15 to 23 also by 1s, and turn my plots off, just because I was just doing that thing, right? Okay. I can trace that to 2006. I can also go over to my table. Remember, if I have my table on auto, 6 will just be one of my options, versus I can manually set my table and just ask it whatever I feel like 6. Now be careful. Read the graph explains a graph. If you write 16.65, one off. Okay, this is in thousands. So 16,650. Okay, find the number of visitors in 2006. Check. When did that pass 20,000? Okay. Now, 20,000 when is it? In the year 2007 is my guess. How do I know for sure? Okay. Remember, I can't actually ask the whys, and I don't know why, ironically. We're close. I can go over here and just plug in 2000, which I think is 20 on my graph, right? Or 20,000. Yeah. And then when I go to my graph, I can now calculate my intersection between yellow, blue, guess, I don't care, tell me the answer. And it says, yep, in 2007. If any of you wants to be facetious about it and go tell me exactly when in 2000 down to the minute and second, have fun. I'd recommend you have the rest of the test done before that. So I would say approximately f of 7. So I would say in 2007. Be careful with your wording. Like some in 2007, after 2007, not at 2007 kind of thing. Okay, so we got that, we got that. Zeros. Set an equal to 0 and solve. Negative 15 is 8 over 3x minus 2, negative 8, I should say. And, y'all remember Jesus fish? Cross multiply and divide kind of thing. Okay. It's called a cross product. If I take negative 8 times 1, negative 15 times the stuff, subtract 30, divide. And that's a 45. And negatives will cancel out. Okay. Plug in 0 for y and solve. Y-intercepts. Put a 0 in for x and solve. 8 over negative 2 is negative 4. 15 minus a negative 4 is 19? Yeah. Find f of 2a minus 5. So that's 15 minus 8 over 3 of these. 2a minus 5. Honestly, the biggest error that I see with these is kids will just forget to put that minus 2 on there. Like the other part of the denominator. And then, Disturbert. 6a. Negative 15 minus 2 is negative 17. I would accept it like that, or if you want to get common denominators, feeling frisky, you can, getting 90A minus 225, 30, 255, 8, negative 263. Okay. Not necessary. If you leave it like this, I'm fine. If you want to combine, also fine. Just make sure whatever you do is in a simplified form. And finally, symmetry and justify algebraically. Do y'all know what that graph looks like? If I got no idea what that graph looks like, come on, Frank. Wake up, Frank. Okay. Say 1 over x L cubed and graphify. What does that look like it's symmetric to? Origin. My rule for the origin, remember all of your rules, if it's symmetric to the x-axis, negate the y's. Symmetric to the y-axis, negate the x's. Symmetric to the origin, negate both. So state the symmetry. I'm going to say origin. Justify algebraically. I should now be able to negate f of negative x. Getting negative x cubed. Negate both the f of x and the x itself. Getting negative f of negative x is a negative 1 over x cubed, right? 3 negatives on denominator means the whole thing's negative. And then, if I divide by negative 1, turns out I still get the same thing. The continuity at x equals 0. Our continuity test is, step 1, does f of 0 exist? Thou shalt not divide by 0. Nope. Limit. The limit of my function as x gets really close to 0 means, now, if I got the graph, I should be able to just look at it and say, as I come at 0 from both sides, it ain't going in the same place. But I can also get that table back over to ask, and I can get really close to 0 on this side, and really close to 0 on this side. One of them's headed to infinity, the other's headed to negative infinity. Those are not the same thing, so my limit does not exist. In step 3, does my function value, not theta, does my function value equal my limit? So in this case, fails 2 ironically meets 1. So it is not continuous. You tell me what type of continuity was that? Infinite, because there was an asymptote there. So I'll say infinite discontinuity at x is 0. Now it's important that you say at x is 0, because everywhere except 0, this thing was continuous. It's just there that it's not. Okay? The time works out. Phones to the counter. Here we go. Please make sure they're